Chat is meetings. I got it. Understanding the language. Yeah. Yeah, you're almost near, but can you be a little bit more clear, Krishna? Like, what exactly? Who is understanding the language here? Is it you, or is it me, or is it someone else? Yeah, machine. Correct. Correct. Yeah. So the machine. So Krishna is correct here. So what we're trying to do is natural language processing is nothing but letting the machines, the computer, understand our language. So we talk in various languages. So I can talk in Telugu. So you guys can talk in probably Telugu and one more language, Hindi or Tamil or Malayalam. So so for the machine to understand our language, we need to teach the machine as the same way we teach our kids or anything. So so how exactly do we do that is basically the natural language processing that we learn. And so there are obviously multiple issues and multiple ambiguities that we have to solve while letting the machine understand, because machines are not as intelligent as humans, right? So it will be a little bit difficult for them to understand language. So that is where we come in, NLP people. So we develop methods, we develop methodologies, we use pre-existing models to encode the language inside the machine so that that can be used if we want to talk with the machine, basically. So yeah, so we can. So what is NLP? It can broadly be called as computational linguistics, which is not really the same, but because computational linguistics deals with more of language part and NLP more deals with the machine part. So basically the mathematics of it. So yeah. So anyone, again, I'll just ask another question. So how do you think we let the machine understand the language? So what can be the process? So if I'm teaching you a new language, then I'll just say like, okay, this word is cat and this word is dog, and then you'll understand after rehearsing it for a couple of times. So does anybody have any idea on how we can do that mathematically to a machine or a computer or a code? If you have any ideas, just let me know in the chat. Otherwise, I'll continue. Okay, fine, I'll continue. So basically, language deals with multiple parts, right? So there is a syntax, which is basically how you write the language. And so for now, we are talking about natural language. We are not yet into computer stuff, right? So yeah, we have syntax. Syntax is nothing but, so if I say I have a cat, so I is a pronoun, have is a verb, and cat is a noun. So these all is syntax. So and based on syntax, like so you have a predefined syntax for each language. So Telugu has different syntax, Hindi has different syntax, and English has different syntax. So based on each syntax, you develop grammar, grammatical rules. So as to say, like, so I cannot say I cat have a, right? So I have to say that I have a cat. So that is grammatical rules. That is grammar. So how you so that both the syntax and grammar are almost interrelated. So they both exist together. So we have syntax, grammar, and morphology. So morphology is nothing but word level understanding. So so have is a verb, cat is a noun, I is a pronoun. So this all comes under morphology. Like for now, you can think of it as parts of speech, which we did in like first, second classes, right, in English and childhood. Yeah, and these are basic level, broader level of understanding the language. And if you go a little bit deeper, you will get pragmatics and discourse, which can be used to understand the context of the sentence. So yeah. So basically, processing of language content is what NLP applications do. So they process the language, natural language, and then they tell it to the machine, and machine will understand it, and then it will give us back a response which we can understand instead of giving ones and zeros in binary code. So both NLP consists of both text and speech, but we'll be dealing with mostly text here. I think speech has another session for it, so we'll be dealing with mostly text only. And yeah, so it's basically, as I said, it's about identifying language phenomena. It's about identifying grammar and then morphology, and basically letting the machine understand. And let's go to the next slide. Yeah, so there is just a definition that I've borrowed from the internet. So it's natural language processing as field of computer science, AI, and CL, concerning the interactions between computer science and natural languages. So so how many of you have used ChatGPT already? Just a quick raise of hands or yes in the chat would help. Yes. Only Krishna seems to. Oh, okay. With ChatGPT, I think many people have used. Fine. You can also ask ChatGPT for the questions, for the answers for the questions I ask. It's not a problem. Yeah. So Bing. Okay. Bing search. Okay. So the people who are mentioning in the chat that they've used ChatGPT, how do you think ChatGPT gives answers? So if I just if you open ChatGPT and ask it a question, what is NLP? What do you think is happening inside it? So it's not a person sitting backside of the computer, right, answering your questions. It would not be possible. So what do you think is happening? Any broad idea? Like, just quickly type in the chat. Using a chat bot, okay, nice. Prediction and generation, right? Nice. Yeah, they trained the machine. Okay, AI bot. Okay, we know that it's an AI bot, Pawan, but what do you think is happening inside the AI bot? Previous knowledge, okay. Lots of data sets and modules, previous actions, okay. Yeah, pre-trained models. Okay, fine. Okay, I think you guys know a little bit of, yeah, I think, yeah. It picks out and searches the keywords. Oh, yeah. That is how actually Google search started. And it's a little bit more complicated than that right now. But yeah, the basic functionality is the same. It picks out and searches the keywords. Learn and give an update, correct itself. Okay, nice. Correct. Okay, fine. Yeah, these all ideas are correct only. We'll see through the sessions like how exactly. Maybe if you want, I would also like to have a session on how chatbots work and like entire process and then the workflow behind it. So for today, we'll just stick with the introduction. This is good to know that everybody knows how language models are working. And yeah, so it's basically so representing the language mathematically. So we have to encode the language in a common format that which both we and the machines can understand. So which would basically be mathematical numbers. So how we do that? So the way of representing words and sentences and paragraphs and mathematical numbers, we can do that in multiple ways, and we'll get to it. And but the basic idea remains the same. It's to identify the structure of the language, the meaning of the language, the meaning of the words, and then the sentences and the paragraphs and conversations. So it's basically to let the machine know. And okay, so and also to develop a deep understanding of the broad language, right? So it's not like if I just say a couple of sentences or let's say 100 sentences in English, and we cannot expect the model to learn the entire language, right? So we need huge amount of data for understanding the language. And what could be a problem with having huge amount of data? It could be possible that it's not generalized. So let's say I have data on mathematics. So all my paragraphs are related to maths formulas and maths equations and some blah, blah, blah. So the model would be able to learn only information related to mathematics. So the model will be learning whatever we are teaching it. That's it. So it is not a it's not a god, right? So it doesn't know anything that we're not teaching. So it cannot search the internet, at least for now. Maybe if the AI takes over, then it can, I guess. Yeah. So basically, NLP is all around us. It's just a language. So there's a small meme here. So you can see that we talk to dogs, right? But what I think is the dogs only understand the name of the dog. That's it. So if the dog's name is Ginger, whenever I say Ginger, it gets activated, like it gets happy, and then after that, it doesn't understand the language. And maybe we can also train the dog using keywords, right? So if I say sit, so if I do conditioning, Pavlov's conditioning, then it might be possible that I can make the dog sit actually for the food. So that is entirely different, but fine. Yeah, so some early NLP history. So how did NLP start? So does anybody have any idea on how automatons work, like automata theory or anything? Okay, fine. So it's basically, so first how it started. Yeah, regular language, correct, perfect. So yeah, okay, nice. So it's basically set of rules. So so how it started was as a set of rules. So let's say that I have hundreds of sentences which start with I have a. So the first three words are I have a. So we can create a probability network having probabilities of consecutive word occurrences. So let's say I have a, let's say the sentence is I have a cat, right? So we'll develop a mathematical model which has the probability of have occurring after I and a occurring after have and cat occurring after a. So that is how NLP started. It started as a sequence. So people assume language is a sequence. At least that's how they started to let the model know. And after that, I think after that, many complicated systems came apart, and then we people are also understood that language is not just a sequence; it's a combination of context, syntax, semantics, and everything. So it's often possible that we might not mean what we say. So that also we have to take care, which is and it's also possible in speech that we can highlight certain words and which cannot be possible in text. So that comes under pragmatic. So there are multiple concepts that came after people started working in NLP. And yeah, and people also first speech systems, and then they started with machine translation. It was highly used by military, I think, because there were wars at that time in 1950s. Yeah, and I think 1960s, 70s, people started to make the understanding process a little bit more complex by making it a little bit more mathematical. So this is where deep learning models started to arise. And so, and then in around 1980s and 1990s, people also understood that the more amount of data we have, the better the models would be. So that is where corpus-centric methods started rising, and people also started to analyze the language more, properly. So computational linguistics also started to play a part at that time. And if you go to the next slide. This is just again 2 generations of NLP. And yeah, so how do we process the language? So how do we let the model and computer understand the language? So what are the steps that we have to take? So it's not like I give a sentence and then write a function to it, like translate, and then it will just make the model understand. It doesn't work like that, right? So how do we do that? We have to process the language first. So there are different types of pre-processing techniques, and then so this all comes under in the path of representing the entire language as a mathematical, like as a vectors or representations or mathematical numbers. That is how that is where the machine will understand. It will not understand words. It will not understand sentences. It will understand nothing. Only numbers it will understand. That's it. So what do we do for that? So let's say we have a sentence. So I'll just first briefly explain this and then we'll go into the details. So lexical level of processing is basically where we have parts of speech. So before that, we do tokenization. Tokenization is nothing but if I have a sentence of 10 words, I'll divide the sentence into 10 words. That's it. It's basic space segmentation. That's it. And also if there are punctuations, then it will be a little bit difficult. And parts of speech, and then we assign each token their corresponding parts of speech. So if it's a noun, we assign it as a noun. And then if it's a verb, we assign it as a verb. And then what do? We lemmatize that word. We stem or lemmatize that word. So basically, so if you have a word, say caring, say caring. So caring is an ing form of the word care, right? So lemmatization splits the word into care and then ing. So that would decrease the noise in the sentence. So ing and then is and a are noise. So let's say we have so let's say we have a sentence, we are going to the mall. So what words in the sentence do you think are the most important to catch the meaning? So I'll just build this question in a different way. So by removing what words, do we still have the meaning left in the sentence? If you're getting my question. Like what words in the sentence are the most important? Any ideas? Okay, nouns and verbs. So what are the nouns and verbs in the sentence, Prasad? Any idea? Okay, fine. I'll take it. So I would say that we, going, and mall are the three words that are the most important. So we going mall. So if I just say we going mall, anyone would obviously understand that we are going to the mall. So I don't need are and to and the to let you know that I'm going to the mall. So that is where attention. So attention and then like a stop word. So these all. So we can understand intuitively that some words are not as important as other words in language, right? So some words are just there just because they need to be there. That's it. Sir, we are going to mall, we are going to the mall, we are going to a mall. So it doesn't make any change in the semantic meaning, in the semantics of the sentence. It doesn't change anything in the meaning of the sentence. It might change a little bit like the mall or a mall or like any specific mall, but we would be understanding that we are going to the mall. So, so these three words are, to, and the. So these are called stop words. So in this particular sentence, are, to, and the are called stop words. So stop words are nothing but redundant words that are not necessarily important for the sentence. So as part of lexical preprocessing, after tokenization and then parts of speech, we also remove these stop words from the sentence so that we can have a better representation of the information in the sentence. So you're with me, right? Okay. Sentence is not visible. Oh, I have put it in the chat. I don't actually have it in the slides actually. Oh, is it a direct message? Oh, sorry guys. I think I sent to Aditya. How to get this away? Meeting group chat. Oh, very sorry. I didn't. I didn't know that I was putting it direct. So this was the sentence. We are going to the mall, and we going mall are the important words, and are, to, and the can be assumed as stop words. So if I just have a sentence called are, to, the, you wouldn't understand anything. Nobody would understand anything. But if you have a sentence, just have we going mall, you would get the idea of what we're doing. So that basically, that intuition is what differentiates what are important words and what are stop words. So basically at lexical pre-processing, we remove these stop words to have a better representation of the language. That's it. Yeah. And what do we have? And we have parsing and chunking. So parsing is almost similar to word level lexical pre-processing, and chunking is a little bit different. So let's say we are going to the mall, right? So we are going to the mall. So this is what a chunk sentence would look like. So chunk sentence is nothing but we divide the sentence into noun phrases, verb phrases, and then adjective phrases. If there are any other and independent clauses or anything. So basically, we are as a noun phrase, going to is a verb phrase, and the mall is also a noun phrase. So we have two noun phrases and a verb phrase here. And every sentence in English would have a verb phrase, because without a verb, you wouldn't have a sentence. It's not possible to have a sentence without the verb. So yeah, this is what chunking is called. This is a simple example of what chunking is. And semantic tagging, yeah, so semantic tagging, let's say I have a sentence which is, how do I get this? So semantic role labeling is nothing but giving the semantic role that the word is playing in the sentence. So I'm thinking of a disambiguated example here. What is this? I think I have some of them in the, yeah, got it. Yeah. So let's say we have a sentence like call me an ambulance. So what do you understand from the sentence? What are the possible meanings that any person would take from the sentence? Or does the sentence only have one understanding? So if I say this sentence, everybody would understand the same thing. Any idea on what possible meanings could this sentence have? Just quickly on the chat if anybody is active, basically not sleeping. Okay, fine. So this sentence would have two different meanings, right? So one is I'm asking you all to call me an ambulance. So my name is Akhilesh, but from today, my name is ambulance. But that is one meaning. Obviously, it's not making sense, but it's possible that a person who is new to the language can understand, can take this as with that meaning, right? And so there is one more meaning possibility, which is call me an ambulance. Really, I am dying or something, and then call me an ambulance. So these two are two different meanings. So ambulance is having two different word senses. So this is where word sense coming. So ambulance is having two different word senses in this sentence. It might not be having the same two different senses in other sentence, but in this case, it's happening. So one more thing that we have to do while making the model or computer understand this language is what word sense of ambulance am I using here? So that is where word sense disambiguation comes in. So that is another low-level NLP task. It can be a project also, actually. Yeah, I don't know what projects you guys will be doing. I'll have to talk with people for that. Yeah. And there will be, after this disambiguation, you will have named entities. So named entities is nothing but, so it's named entities are proper nouns, basically. Mostly you can basically understand it like that. So call me an ambulance, this sentence doesn't have any named entity. But if I say Taj Mahal is in Agra, so we know that Taj Mahal and Agra are both proper nouns, not because I wrote it in capital, but they are proper nouns. So these two are proper nouns. So these two are named entities. So these would be more important to the language. So this is basically making the, so in order to let the computer understand the sentence, what we do is we take out important words from the sentence. So that is where all these processes come in, where word sense disambiguation, semantic roles, named entities, and then lemmas, and then removing stop words, everything. So, and then we also have discourse level segmentation, which is so basically to understand the context of the sentence. So it might be possible that some of the information might be lost if you don't provide the context, right, of the sentence. So that is where the discourse comes in. And speech, I'll skip it for now. And yeah, so how are the trends going on in NLP these days? It's basically enormous amount of knowledge is now available in machine readable form. So we have like billions and billions of web pages on the internet, which we can use to train any model we want. So if I just want to train a model which generates Twitter tweets, I have billions of tweets right now in front of me. And if I want a model that would be answering in a sarcastic way, I have millions of sentences which are filled with sarcasm. So basically, there is no general level artificial intelligence as of now. But if you want the model to perform for a specific task, you can use the corpus. You can select the corpus in such a way. Basically, that is what. So depending on the corpus, and the model will be able to will be training and then performing in a similar way. So the way your corpus is, the way the model performs. So if the corpus is better, the model will be better. If the corpus is noisy, the model will be noisy. It's similar. They're directly proportional, we can say. And much of the human communication is now mediated by computers. We can see like we have WhatsApp chats, mails, and then tweets, Facebook messages, and then everything. So all these messages so can be used if they're publicly available for training. And then and these also have code mix language. So if I know Telugu and English, right, so I can speak in I can write Telugu in English, and then so that is what code mixing is. So basically combining two languages in a sentence. So does keyboard is an example for what exactly? Oh, human communication. Oh, which gives the next word suggestions. Yeah, correct. Okay, you're talking about the touchpad in the mobile, right? I was assuming it was the actual keyboard. Fine. Yeah, I understand. So that is one of an NLP application, exactly. So NLP is before you every day. So if I am typing, so I am going, and then it'll all auto suggest to me that the next word is two. And then if I'm going to mall every week, it'll auto suggest me that you have to go to mall this week also. You forgot about that. So yeah, that's exactly. Even it's those Telugu words typed in English. Yeah, correct. Yeah, that is basically you're training your own custom model. So every time you type a word in your keypad, it stores the information, it stores the context, it stores which word is occurring after which word. And then the moment you have three words together, it will predict the fourth word. That is how. Yeah, correct. So as I said, these are the four different levels in which a language can be understood, like word, syntax, meaning, and then discourse. We'll go deep into that later. And yeah, so this is I've just explained, right? So it's these are the challenges with language. So it's not as easy for a machine to understand. Maybe if a person is talking to another person, they will have the context behind them. They'll have the surrounding. They'll have the where the geographic location where they're in, and multiple factors come into play when you're talking. So it's not just the chat. It's not just the chat. The person who is talking, where are you talking? How many people are watching you? Then it all makes a difference in what the sentence might represent to other person, right? So there are multiple levels of ambiguity in language that we need to solve in order to create a chat GPT, I would say. Yeah. And so here, just an example, call me an ambulance from now on, I'll call you an ambulance. Okay. Yeah. So that is not what we want, right? If I'm dying and then the Siri or Google Home replies me like this, and then, yeah, I'll be dying. Yeah. And there's one more. So there's one more example. So San Jose cops kill man with knife. So what exactly is happening here? So do the cops? So there are two different chunking. So this is a graphical representation of chunking. So we'll have a noun phrase, verb phrase, and then noun phrase, and then what is this with a prepositional phrase. And so basically, so you can understand what are the two different meanings for it, right? So San Jose cops kill a man who has a knife. Or it might be possible that San Jose cops are killing the man using a knife. So the knife here has two different semantic roles, right? Two different roles. So one is a object here. So one is in the first case where the cops kill the man with the knife using a knife. The knife is acting as an instrument for the action. But in the second case, it's not. In the second case, it's just an object that the man has. So this is the types of ambiguity that we need to resolve while we're dealing with NLP systems. And these are like a couple of examples of like ambiguous headlines. And so this is basically misinformation can be spread using this ambiguity, because hospitals are sued by 7 foot doctors. So are the doctors actually 7 foot, or these are 7 foot doctors? So yeah. There's a daily examples that we see everywhere, every day. And pronoun reference ambiguity. So let's say we have a dog, and then the doctor, and then so Dr. Macklin offers brings this dog Champion to visit with the patients. He just loves to give big wet sloppy kisses. So is it the dog or the doctor that wants kisses? So these are the different types of ambiguities. And what are the other challenges that we have? We have millions and billions of data, right? So Wikipedia has 2.9 billion words in English. Words as in repetitive, obviously. So we have to clear out the noise. We have to sample out the perfect sentences, and we have to sample out the correct sentences. So all these we have to do before developing an NLP application. So let's say we are developing an NLP application using the sentences on the internet, and some of them are not true. So if you, who will trust your model if your model is based on, let's say, news articles? So it will not be that, what do you say, reliable, right? So reliability is also an important thing that people need to take care when they're developing models. So how reliable is this data? How good is this data? So we know that we have billions of words on the internet, but how good is it? That's important. And I would just say these are like same steps that I've explained. First, we deal with morphology. which is basically to split the words. So if I have caring, so I'll split into car and care and then ing, and then the syntax, so which word is occurring after what, and the grammar of it. And then semantics is nothing but understanding the meaning. So which word is representing which of its meaning at this point. And then pragmatic. So I'll just have a brief intro to pragmatics. I'll just give one example here. So let's say, so I have a she stole, or let's say they stole. I'll just not call he and she now. They stole my wallet. So let's say I have the sentence, they stole my wallet. So I can, while talking, I can highlight each word in this sentence and make it look like they have different meanings, right? So they stole my wallet, or they stole my wallet. They stole my wallet. They stole my wallet. So how I talk would increase the importance of each word here. So they stole my wallet is I am blaming someone that they stole my wallet. And they stole my wallet is basically I am sad about the fact that somebody stole my wallet. And they stole my wallet is like there are many people around me. Why did they steal my wallet? So that is where pragmatics come in. So which word in the sentence and what is the speaker trying to highlight about? So are we getting the exact meaning that the speaker is telling us? Because there is no voice in NLP, right? So it's on text processing, we wouldn't have voice. So all we have to do with pragmatics, like, so is there a way that we can represent which word is important? So that is one question. And then discourse level is basically context. So if you have a paragraph and then if you have two paragraphs, one sentence would have a different meaning in each of the paragraphs, right? So that is where discourse level understanding comes in. And so the objective is basically to understand the challenges, what are the tasks required and what techniques that we can use, mathematical and NLP and deep learning or any machine learning or anything, what techniques that we can use at every step in NLP, natural language processing, to develop a model that is at least better than a probabilistic model. Yeah, so the focus would be on textual NLP and for the area of interest, yeah, this would be unnecessary. It's fine. So how many of you know Python? Is anybody? So is it, if it's, would it be fine if I just show a small code in Python? How can you do a chunking and then tokenization of words, like simple code? Okay, fine. Okay, only 2 people out of 96. Okay, anyways, it will not be that. So there is a NLTK. Maybe you guys can just go through it and then like understand what's in there, what all pre-processing techniques would be there, and then what we can do. So given a sentence, how can we play with the sentence? That's what it does. So it would be good if you can just look upon in the internet like what's there and what can we do. So yeah. So I just have a tokenizer. So tokenization is nothing but the process of segmenting the sentence into tokens. So I divide the sentence into words, basically meaningful words, not anything but meaningful words. Yeah. So let's say have an indicator tokenizer. I don't remember what is this actually. Okay, send tokenize. Okay, word tokenize. Fine. So it's tokenized, not tokenizer. So I'll just import a word and then now. So let's say I have a sentence. So which is I have a cat. Or maybe if you have complicated sentences, please let me know. So I have a cat. So what do you think the tokenizer does? It basically segments the word into the sentence into words. So words, let's say I store the words in list of words, and so this would be basically word tokenize of sentence. Would this work? Yeah, correct. So it just tokenizes the sentence into words, right? So this is the first step. If you want to build anything ranging from a probability model to chatbot, The first step you have to do is to tokenize the words. So given a sentence, you have to differentiate all the words and then store it as a list of words. That's it. Oh, screen is not visible. Oh, the code is not visible. Arey bhai. My bad. Wait a minute. Is it visible now? Ah, okay, fine. Sorry for that. I didn't know that I was sharing only the slides. Yeah, so I'll just go through it again, just to make sure that all of you are. Hmm. So let's say, so I import the NLTK library. So this is the name of it, NLTK. Please note it down and then go through it once. So just to make sure. Yeah. And so let's say I have a sentence, which is basically I have a cat, I have a brown cat. I'll just include one more word. Yeah. And then what will I do is I'll store this in, so I'll process these words, a sentence into words. So that I can do using the function called word tokenize, which is an NLTK library. It returns a list of words after taking a sentence. So, oh, my bad. So this is how it tokenizes the sentence. So I have a brown cat, it differentiates into I have a brown cat, full stop. So so this can be used to, so now after this, what you do is we remove the stop words. So if let's say we have a stop words. So let's say we have a list of stop words. I, A. So let's say we have this list for now. So what do? We iterate through the stop words for words in words. Okay, doing it in a Python in a file actually would be better, but fine. I'll just stop this for now. So you understand what I'm trying to do, right? So what I do is I have a list of stop words. I have a list of words. So I'll remove all the words which are in stop words. So the final list would be a have brown cat. Full stop also I have to remove. So have brown. So yeah, I would not be a stop word. My bad. It should not be a stop word. I is very important in the sentence. So A is the only stop word. So I have brown cat. So that is a information that you need to understand the same meaning. Yeah. Oh, the NLTK is a platform used for building Python programs. Okay, yeah, fine. That is correct. Yeah, that is how where NLTK is used. Good. And so basically, so we iterate through the stop words and then remove these words if they are in the sentence, and then we would have a meaningful set of words that we require for understanding the sentence. That's it, right? And what do we do after this? We do POS tagging. So POS tagging can also be done using NLTK. I would prefer you guys to go through it and then like try it on your own if you know Python. Otherwise, I would be sharing all the Python files by tomorrow and like basic level pre-processing, and then I'll just share the codes. But try it for today. And if you have any doubts, just note them down, and then we'll be talking tomorrow or whenever the next session is. And yeah, so this is how stop words work. And so if you want stemming, so let's say I change the sentence to I have a caring cat. So what do I do is I import nltk.stemming. So Porter stemmer is the one which we usually use for normal stemming. It's enough for basic English and English words. And so we then define a stemmer object. So then we use this to find out the send. So let's say, so what do we do? So as you know, to do anything, we first need to do the tokenization, right? So let's say we do the same thing again. So word tokenize we do, and then we give the sentence as input. So this would store all the words you can see here. So I have a caring cat. And what do? We pass each of the word into the stemmer. So let's say we pass let's say we pass the last to second word, which is caring. So this would give care as the output, right? So ing is not required. So for the I have a care cat, like I have a, so you can understand the meaning, right? Even though there is no ing form, ing is just for the grammatical sense, just so that it sounds good when you listen to it. That's it. That is how the language has evolved. So and so care is enough information in the sentence. So have care cat I. So that those four words would be enough to understand the language. And what more processing can you do upon that? So that is where all the NLP techniques come in, and we'll discuss them detailed. And I would say, yeah. So you got a little bit, like, I know this is very simple, but as an introduction, like, I think you understand what's happening here, right? So how does like, what do we need to do in order to let the machine understand any sentence? So yes or no in the chat. Or if you want something better or something more complicated, I can come up with it next time. And because I didn't know what you guys are expecting, so yeah, please let me know in the chat. Understood. Okay. Okay, only ready, understood, but fine. Okay, fine. Yeah, okay. So this session was just to, like, let you know how basic NLP works, and then all the techniques and mathematical techniques that would come up. I think so. Have you guys gone with, like, or do you already know, or did anybody teach you anything about deep learning, neural networks, and then perceptrons, multi-layer perceptrons, anything like that? We have academic. Okay, in the courses that you have already studied them. Okay, fine. Then it's perfect. Then I think this all should be like a very introductory session. ML, DS, DA. Oh, nice. Oh, okay. Then we can move a little bit more complicated. I think this is very basics. Okay, fine. Yeah, I think that's it. So I covered most of the things that I want to cover for today, at least. So yeah, so for now, I think I'll stop the session. We know a little bit basic parts. Okay, fine. Yeah, that's fine. Okay. So I think we'll stop the session for today, and then I now understand, like, what all you are expecting and what you already know. So then this would make me prepare better for the next one. And yeah, I think that's it. So if you have any doubts, just let me know in the chat quickly. And okay, yeah, fine. Okay, ready. So do you think this already what you already know, that what I just taught, or just it became redundant, or did you learn anything new, at least a little bit? No doubts. Okay, fine. Okay, then if there are no doubts, and we haven't done any practical experience on ML using Python, it's new for me. Okay. Okay, then. So do you want the sessions to be how many, like 6 or 7 more? I don't know how many will I be taking, but do you want them to be practical, like using code, or do you want them to be descriptive, as in slides or anything? Okay, both. Okay, fine. Code for me, it will be helpful, sir, if you come with more coding part. Code. Okay, code. Okay. Practical. Okay, fine. Okay. Okay, one more code. Okay, then. If coding is what you want, then coding is what we'll teach. Fine. It works. Both. Yeah, fine. So I think what we can do is we'll select what topics we can discuss, and then like a little bit implementation, basic level implementation of the code of it, and so that you'll understand the entire workflow or anything. So just explaining wouldn't make sense, right? So just like you'll listen to it and then you'll forget. But if you see the code, if you see the sentence segmenting itself, then you'll understand. You'll remember it forever. That is correct. Happy to know that everybody is interested in coding. Okay, then. So you can leave the meet, and I think I'll be there if anybody has any chats or anything. Try to teach with code. Sorry. Okay. Okay. Fine. Yeah, I'll try to. Thanks for the suggestion.